In this video, we're going to take a look at solving problems using what are known as power reduction identities. So the power reduction identities can be derived from the alternate equations for cosine of 2a or 2 theta or whatever your angle is named. So we took a look at, in the first video, where cosine of 2a equals cosine squared a minus sine squared a. We have two alternate versions of that using Pythagorean identities. So for cosine 2a equals 2 cosine squared a minus 1, if we solve this equation for cosine squared a by adding 1 and dividing by 2, we get cosine squared a is 1 plus cosine of 2a all over 2. And if we look at the other alternate form where cosine of 2a equals 1 minus 2 sine squared a, this should actually read sine squared a, solving for sine squared a here. Subtract 1 and divide by negative 2, we get sine squared a is 1 minus cosine of 2a all over 2. So these are what are known as power reduction identities. And you'll see these in calc class, usually either calculus 2 or BC calculus, where you have to integrate something like sine squared a or cosine squared a. You'll have to use these identities in order to do that. So example 5, rewrite sine squared theta cosine squared theta as a sum and difference of cosines all to the first power. So if we look at sine squared times cosine squared using our power reduction identities, sine squared is 1 minus cosine of 2 theta over 2. Cosine squared is 1 plus cosine of 2 theta over 2. So if we multiply all these out, in our numerator we have a difference of squares that multiply to make 1 minus cosine squared 2 theta. And our denominator we have 2 times 2 is 4. So here we have 1 minus cosine squared 2 theta all over 4. However, it does say that the cosines, we want to rewrite this where the power for the cosines is the first power. So unfortunately, this squared cosine function here isn't going to cut it. So if we look at cosine squared now as 1 plus cosine of 2 theta over 2, we're not evaluating this particular one in red here at theta, we're evaluating it at 2 theta. So we're going to substitute in for theta a 2 theta. It's a function composition here. Well, if we substitute 2 theta in on the left-hand side, we also have to substitute a 2 theta in for theta on the right-hand side. So in our right-hand side, we have 1 plus the cosine of, this is the 2 here brought right down, and instead of theta, we're evaluating it at 2 theta. So it's 2 times 2 theta. And again, that's all over 2, which is 1 plus cosine of 4 theta all over 2. So substituting our cosine squared 2 theta as 1 plus cosine of 4 theta over 2, we're just going to take this expression and substitute it back into this equation up here. What we end up with is 1 minus the fraction 1 plus cosine of 4 theta all over 2, and that's still all over 4. So again, we just took this expression in red on the right-hand side and substituted it back into what we got after the first step or two. If we multiply everything by 2, that'll clear out our fraction here with our tiny denominator. So we get 2 times, 2 minus the expression 1 plus cosine of 4 theta. Don't forget, we do have a minus here. We will have to distribute all over 8. And then distributing our negative through, we get 2 minus 1 minus cosine of 4 theta, which simplifies to 1 minus the cosine of 4 theta all over 8. All right, so that about does it for this video. Thanks for watching. I'll see you next time.